I'm Roman Rodriguez, and we are on chapter 10, heat. And this is the sixth lesson where I'll be solving the two problems on page 206 from your textbook. So let's begin. First, we look at 10.4. I'll just write down the data. Now it says here that if a given mass of gas has a volume of, now it has a volume of 4.5 times 10 raised to the power minus 5 meter cube at a pressure of 30 kilopascal. Let's say this is V1 and V1. What will be the volume? What will be the final volume of the gas if the pressure is increased by 50 kilopascal? Okay, while the temperature is kept constant, T1 and T2 are both equal. Now, we'll apply the general gas equation, that is solution P1 V1 upon T1 is equals to T2 V2 upon V2. So, initial pressure is 30 times initial volume 4.5 times 10 raised to the power minus 5 meter cube. T1 and T2 are same, so they can cancel out. So they are both equals to T, whatever the temperature is. P2 is 50 kilopascal and V2 is what we need to find out. T and temperature will cancel out. We need to find V2, so let's bring 50 on the other side. So we get V2, the final volume is equals to 30 times 4.5 times 10 to the power of minus 5 over 50. Now when you shift this decimal point, we put a 0 here. The 0 and 0 will cancel. 5 tens are 5 nines are 45. So final volume would be 3 nines are 27 times 10 is power minus 5, and this you need to get on top will be 10 is power minus 1. We can write V2 as 27 times 10 is power minus 6 cubic meter, or final volume is 2.7 times 10 is power minus 5 cubic meter. Okay, we are both correct. So this is the answer. Now let's move on to 10.5. Just write down the date of this. It says here a bubble of air rises from the bottom of a pond to the surface. Just before the bubble reaches the surface, it breaks and the volume was double its original volume. Now let's say the original volume of the bubble is X. So the final volume it will be double, that is 2x. Now the water has a uniform temperature. Again, the temperature T1 and T2 they are both same, and its density is 1000 kilogram per cubic meter. Now density is denoted by the letter rho, Greek letter, and this is 1000 kilogram per cubic meter. The atmospheric pressure is 10 to the power of 5 pascal. Pressure is equals to 10 raised to the power of 5 pascal. Estimate the depth of the pond. You have to find the height of the depth of the pond is equals to how much. Now, general gas equation P1 V1 upon T1 is equals to P2 V2 upon T2. Since the temperature is same, so they'll cancel out. The pressure is given to you as 10 to the power of 5. Volume initially it is X. What will be the final pressure? Now you know, according to Boyle's law, if the volume increases, the pressure decreases. Now here the volume is double, that means the pressure will become half. So we can write P2 upon 2 half when the volume is double, that is 2x. Okay. No? Now x will cancel with this x and this 2 will go with this 2. So you have final pressure is 10 to the power of 5 pascal. Now, you know that pressure is equals to rho GH. We have this formula. We derived this also. earlier. So let's keep pressure as 10 to the power 5. Density is given to us as 1000, that is 10 to the power 3, times G is 9.8, acceleration due to gravity, and we need to find the height h. So 10 to the power 5 over, this will come down here, 10 to the power 3 times 9.8 is equals to half. This will cancel, 10 to the power 2, that is 100 divided by 9.8. So let's check the decimal, one more zero here, height is equals to 1000 upon 98. 1000 divided by 98 will give you how much? 0.0, 2 8 so 16, 2 9 18, 196. So roughly around 10.2 meters. This will be the height of the pump. So I hope it is clear to you all, and we'll meet you in the next lesson, lesson 7, and I'll be solving a few more problems. Till then, take care.